Hey, everybody. Can you hear me okay? Give me a thumbs up. Yes? All right, awesome. So my name is Jordan Sterling, and I'm here today to talk about Trust on Board. Today at this talk, we're going to go over what Trust on Board is and how we can use Trust on Board to authenticate devices. And we'll look at why X509 is a really good fit for IoT authentication. We'll see a live demo of this happening, and then we'll see some more capabilities that are available on SIM cards. Before we get started, just want to do some introductions. As I said, my name is Jordan. I've been working here at Twilio for a few years now, and I'm currently a developer on the wireless team. I'm very happy to be joined today by Gerald Monnier. Gerald comes to us all the way from France, and he's here from Gemalto. Gemalto is one of the largest SIM manufacturers in the world, and we've been working very closely with Gerald and his team at Gemalto to help produce a secure solution for anybody using Twilio Wireless. So let's get started. So authentication is a tricky problem. You have to have authentication if you need a secure product. And authentication really is the confidence that if someone is connecting to you and your server, you know who it is. And you can trust if they're providing a credential, that that credential cannot be forged. And it gives you the confidence that if you can establish identity, you can then establish actions that that person is allowed to take. I think... No. Sorry, this is actually missing a slide here. Yes, this is the right deck. Yes, so there are some specific challenges to IoT authentication. I think they're a little different from normal cloud computing authentication. One of the first ones is there's just a lot of devices. Usually if you're doing a cloud computing deployment, maybe on AWS, once you hit 20 or 30 VMs, that's kind of a lot. Maybe at 100 or 200, you're looking at a pretty sizable application. But for IoT deployments, you might have thousands of devices. It's a completely different scale. Also, a lot of these devices are always remote. And you never really get to visit them. And even though the VMs that we rent from Amazon, no one ever visits those VMs either. You're not going to go to the data center and go see them. But you at least have a little more control over them. You can turn them off. You can create them and destroy them. The devices are going to be a little bit more longer living. And the devices, usually once they're out there, they're in someone's hands. And it's a person, so hopefully they treat your device well. But you have to be prepared for them to want to try and break into your device and maybe extract some data from your device. And of course, because this is the hardware, any changes you want to make after the product is already made is going to be a lot more difficult. So going over a few common ways to authenticate. I mean, of course, everybody starts with no authentication. If Hello World required you to put in a password, no one would ever do it. As you kind of get farther along with your product, you do reach a point where you have to add authentication. A lot of mechanisms out there are going to use symmetric authentication, where the client or the device is going to use the same key that is known on the server. So if you're passing a password, you have to have the password that the server has. Even with AWS's time-based signatures API, you still have a secret key that AWS has the exact same secret key. And this can be a little challenging if you want to change or rotate the keys. You have to be very much in coordination with your devices to do that. So what we've kind of wanted to do is do authentication through X509 certificates. X509 is kind of a weird name. It's an international standard. There's other names for it, like TLS certificates, SSL certificates. But we all use X509 almost every day. If you connect to a website over HTTPS, you're using X509. Generally, if you connect to a website, like if you went to https twilio.com, one of the first things you're going to do is receive the Twilio certificate, and you're going to inspect it and make sure it's legit. You're going to make sure it has twilio.com in the certificate. It has some other metadata that you can validate. And most importantly, there's going to be a signature on the certificate that you can verify with a third party, which would be a certificate authority. And if you can verify that the certificate is signed by an authority you trust, then you can sign the certificate. The great thing about this is this happens anytime you browse a website over HTTPS. There's no human interaction required. There's no input. So it's really good for a machine-to-machine case, because there's never going to be a person behind one of these devices. And the certificates can be a two-way verification. So maybe I have connected to Twilio, and I validate that the Twilio certificate is good, and I trust it. But maybe I then have to send my certificate to Twilio, and then Twilio is going to look at my certificate and make sure they can trust it. And they're going to look at my details, and they're going to have to say, okay, is this really Jordan? I don't know. Okay, this was signed by someone else. Let's see if I trust who it was signed by. And if they can establish that it is me, now we have a two-way trust relationship. And that's a very, very powerful thing. We like to use this for the IoT device communication from the device to your application server, or really any application server. And the fact that it's any application server, I think, is another very powerful aspect of it. IoT ecosystem out there has really gained a lot of traction with X509 certificates. The AWS IoT console is completely based off certificates. Twilio Sync is going to offer certificate-based authentication. Azure has also announced that their IoT console is going to use certificates. But really where we think this is most powerful is if we can deliver this as a framework for anybody out there. For you, if you're running an app server, you can take our framework and utilize the TLS certificate verification and make sure that the certificate coming in actually comes from a device that you trust. It's platform independent. So the way that we want to get this done is we want to put these certificates on the SIM card. SIM cards are really, really cool. They actually have file storage on them. They're like a computer in a computer. Gerald will talk more about capabilities of SIM cards later in this talk. And when I say a certificate will be on a SIM card, what I really mean is it's a certificate and the private key. These two files together are what you'll need to do to complete the TLS handshake. And the private key, of course, is the very sensitive one. And I think where this becomes very powerful, of course, if you have a very small number of devices, maybe you have 5 or 10, if you bring them into the office, you can always copy your key or your private key and your certificate onto the device. It shouldn't be too bad. But once you get into a large number of devices, once you want to scale, that doesn't really work. You're not going to receive 10,000 devices from your manufacturer, take one out of the box, plug it in, copy a key over. That's just never going to work. How to scale this is actually a pretty tough problem. On the AWS website, they do recommend you might want to talk to your manufacturer and make sure that you and your manufacturer can agree on a way to get the private keys and the certificates onto the devices. But at this point, your manufacturer is who? They may be your lowest bidder. And are you really going to send them all of these private keys that you have and say, okay, please put these on the devices, and then when you're done, just get rid of them and don't ever look at them again. And they're going to be like, yeah, okay, we can do that for you. And I think that is kind of a hard thing to trust, but it's a little easier if it comes from Twilio. And the main thing that we want to be able to do is make this a very simple workflow. And something that's going to happen when this launches, we'll have a direct integration between Twilio and AWS. So you'll be able to say on Twilio, I want to order, let's say, 10 SIMs, and I'll ship them straight to my house. And then I'll have the ability to put in my AWS account into the Twilio console, and through a CloudFormation template, we will transfer all of those certificates to your AWS account, and we will associate them with an AWS thing in the console. And the idea is as soon as the SIMs arrive to my house, I can unpackage them and stick it in the device. And as soon as it connects to Amazon, Amazon already knows which thing is talking to it. Because this is going to be a Twilio certificate on the SIM, all of the certificates will be signed by Twilio. And we will take care of these certificate authorities, so you don't have to worry about that. But again, this is something that we're going to start on AWS and expand to any platform. And so far, I've been talking about device authentication. But really, if the certificates and the private keys are on the SIM card, we're really talking about SIM authentication. Because if you took a SIM in one device, and that has your private key and certificate, and you insert it into another device, the server it connects to may not realize that there's a different device talking to it. And sometimes that might be okay. At the office, we have a lot of devices. We have a lot of SIMs. We like to play around and move the SIMs around and test things out. But you may actually have a more secure requirement around physical security, and you want to have a SIM that if it's inserted into one device and removed and inserted into another, you wouldn't want that to work. And that can be accomplished using technology on the SIM, which is the SIM pin code. And basically, if you insert a SIM into a device, you can set the pin code after it's been inserted. And then if someone was able to remove the SIM and put it into their own device, they won't know your pin code. And if they get the pin code wrong too many times, the SIM will stop working. So together with the SIM and the pin code, you can decide, because this is optional, if you want to do SIM authentication or if you want to treat your SIM and your physical device as one logical unit and authenticate that unit. The actual offering that we're going to be rolling out is going to involve 2 certificates. So that's 2 certificates and 2 private keys. And the idea behind this is that one certificate is going to be what I'm calling the available key, and that key is going to be readily available for you to use in your application. You'll be able to extract the actual contents of the certificate and the private key, and once you have those in your code, you can do anything you need to do with them. A very common use case of this is if you have a TLS module or a radio connectivity device that requires you to hand over the credential, which would be the private key in the certificate, and they'll take care of the TLS for you. There's another way that we want to work with this, which is the signing key. And the signing key is going to be another unique certificate and private key. And the signing key is a little different in that you never actually get the contents of the private key. It's going to live on the SIM card, but you will never be able to see it. And the idea is the SIM can actually expose functions in code to various applications to work with the private key and maybe perform an operation like encrypt or sign on data without exposing the private key to you or anything on the device. The main difference here is in the available key. Your code on the device is able to read the private key, which means possibly, if there is malicious code on your device, it also could read the private key. But with the signing key, nothing ever gets to read the private key. It's a very, very secure solution. This is typically going to be used with different IoT frameworks that will take care of the signing for you. I used one of these frameworks for the demo that we're going to see in a few minutes. There's a lot of different frameworks out there. There's Embed, Java JCE, and OpenSSL. They can all take care of this signing for you. I know there's a lot of developers out there today. Just taking these 2 methods of storing the certificate, putting them into code. These signatures are more of a simplification just to give you an idea of how it's going to look. But you can see in the available key that you can actually directly access the private key in the certificate. But for the signing key, you don't really get to access the private key. It's still locked away inside the SIM card. And both of these are going to support the bind with device idea using the PIN code. But these 2 keys and private keys will live in isolated environments on the SIM card. So there's no risk of code in one environment on the SIM card using another key from the other environment. So that is the idea behind this, and now we're going to look at the demo. So just to explain how this demo is set up, this starts with Twilio. So on Twilio, I bought some SIMs and I have Twilio-generated certificates on the SIM. And then I've used our Twilio to AWS integration to send my certificates from Twilio to my AWS account, and I associate them with a thing. And each thing is going to be one-to-one with a SIM. And now I have the SIMs, which are actually here in this bag. And we're going to stick these SIMs into a Raspberry Pi. And the Raspberry Pi is going to connect over the MQTT channel to my AWS account. And we'll be able to watch the results coming in on the computer. So I have a beautiful UI over here. So I'm just going to take a random SIM out of the bag. And we'll turn on the LTE module. It's going to take a few seconds to get network connectivity. Still waiting on the network. And we are online. So then I have a program running on this Raspberry Pi that will just send a stream of data into my MQTT topic. There's actually nothing on my device right now that is identifying to my AWS account besides the MQTT URL. I do not have my AWS client ID on the Raspberry Pi. I do not have my AWS secret key. And I don't even have anything related to the things or the SIMs at all. All of the data is actually just contained within the SIM card. So the SIM I put in here now is the red SIM. So that one's going to start inching across the board on the bottom. It's moving. And then what I'll do is just take another one of these SIMs. We can take the red X SIM. And I'll restart the modem. And we'll wait for the modem to come online again. We are almost online. All right. Now I'm going to restart the same program. Haven't made any modifications to the program. And pretty soon we should see the red X SIM start to receive data to my MQTT topic and start inching across the screen as well. And there it goes. So yeah, this is utilizing the embed framework to read the certificate off the SIM, perform TLS, authentication, and then on the server side, in my AWS account, I already have all of the certs that are on the SIM accepted into my AWS account associated with the thing. And utilizing the rules engine on AWS, I can extract out the common name and the thing really from the certificate. And I'm actually using DynamoDB to store the values. And just this page is just constantly pulling Dynamo to see what's the latest data inserted there. And I think Red X is going to win today. All right. Okay, so now I want to introduce Dral. Dral is going to talk more about capabilities that a SIM card has. Take it away, Dral.
Okay, thank you, Jordan. You guys hear me okay? Perfect. Louder. Okay, I think these guys will increase the volume. Okay. Okay, so to better understand this awesome demo, and congratulations for the graphics. Everything was hacked very nicely. We think it's interesting to understand what is behind the SIM and what is exactly a SIM. So of course you all know this dumb piece of plastic you need to insert into your phone to be able to place calls at home. But it's much more than that. If you look at the internals of secure element of the SIM, it's basically a secure chip inside, which runs a program which is dedicated to authenticate your subscription to the network and protect some credentials to prove that you have the right to connect to the network. And of course, this kind of secure chip, you have several in your pocket, in your bag, and they are used in many different domains where we don't want to mess with security. So for example, the main example you probably know is the government domain, where you have EID cards, driving licenses and passports which are leveraging this kind of chip. There are well-known banking cards, not all in the US, but most of the smart card abroad are using that. And of course, now it's inside your phone, your wearables, and where they today enable things like Apple Pay, Samsung Pay, and things which are just coming in. You can protect access to buildings like government buildings and government networks with PIV or DoD cards. And of course in IoT with all the critical infrastructure, the metering and the energy sector. And why not sim racing? So if you look at a bit at the what is exactly a secure element from a hardware point of view, it can be seen as a coprocessor for your IoT device. So it's a separate processor that is connecting to the host processor using various interfaces. So when it comes to the SIM, most of the time we will use a modem with 80 commands for those which are familiar with that. And this is the way to talk to the SIM card. There are other ways to talk about that. And the form factor can be the dumb plastic card I was describing before, but it can be much smaller and soldered directly into the device to resist some vibration, temperature, etc. So it's kind of similar architecture between the host and the secure element. And when you look at the internals, it's kind of similar. We have the same components. It's like another CPU running another machine running in parallel of the host machine. But of course, the comparison will stop here. The performance is definitely not the same. And if you look at the architecture design, the hardware design is much, much more different. On the left, you have a typical IoT device, and if you extract the board, most of the time you can easily reverse the hardware design, identify the different building blocks, find the buses which are connecting the different systems, and do something smart and funny with that. Sorry, I should say bad with that. But you can start with this and play with that. On the right side, it's completely different. Everything is hidden, so there is an active shielding. That means there are some sensors to detect if you are trying to get inside it. Like UV or temperature sensors that will destroy everything if you try to tamper with it. Every logic is glued together in a single chip, so you will not be able to identify where is the memory, where is the processor, etc. And there is no, of course, visible buses that you can spy, and all the exchanges between the different components and the memories are encrypted. So this is how we provide the first level of tamper resistance, and why we are calling that a secure chip. And this is physical security. When it comes to software layer, basically it's like a computer, as I said. On the right, you have the SIM card or the secure element in general. So you can find, starting from the layers below, you can have of course, the hardware, and then you have a full operating system running into the chip. And this operating system is enabling a Java VM, and on top of this Java VM, there are Java applets, so it's called cardlets in this environment. So typically, this is where you will find the SIM applet. This is what makes your SIM a SIM, where the MNO credentials will be stored and protected to prove that you have the right to connect to the cellular network. And there is the, sorry for the name, MIIS applet. So that stands for identification, authentication, and signature that we will use for IoT security. And where the type A and type B, you know, the signature and certificate and private key stuff will be stored and protected. On the left side, you have the typical IoT device that we use for the demo. So the software application, the demo application was written on top of a really standard AWS IoT SDK, which itself relies on embed TLS. And we just configured the embed TLS to use our own crypto provider. And our crypto provider is just taking care of delegating all crypto operations to the SIM card. And doing so, the private key will never leave will never get out of the SIM card and will always be protected. Just to illustrate what Jordan was showing. So, okay, never mind. The animation is not working, but we don't care. On the left, there is this famous TLS stack that some modules are offering, and this is how the yes, you see the green key on the right is disappearing. It's supposed to move. Oh, it's moving. Fine. Directly from the application, fetched on one side and provided to the TLS module. So this is for constrained devices that are not able to host something like TLS or embed or MQTT stack. Okay, so trust on board means from the factory to the field, that everything has been taken care of. All the complexity of issuing credentials, managing them, protecting them has been done already. And all the best practices are already on board. So it's just ready to use. So to make a quick overview on the process. Jordan already highlighted how it will work from your point of view, but behind the scene, what happens in fact is Twilio will ask Gemalto to produce some cards with some pairs of certificates to make them unique for IoT. And Gemalto will manufacture SIM cards, insert these keys inside, insert the subscription, the MNO subscription to make it a SIM, and we deliver boxes of secure elements or SIMs to device makers. And device makers are really manufacturing the same exact things 1,000 times. I mean, they just produce the same thing every time, not diversified at all. And at the last minute, they can just insert or solder a SIM that will become the unique identity of the device and make this device unique. At the same time, the Twilio backend will provision, in the example, the AWS cloud with the certificates of your things, and your thing will be powered on the field. And the first time, it will just connect to the AWS URL and try to publish some stuff or to register to some stuff, and it will be automatically authenticated with strong security and in a plug-and-play manner. Okay.
Thanks, Rob. So just to recap the trust on board, first off, the Twilio SIMs are going to be providing value from global cellular connectivity. One SIM is going to work all around the world. The certificates are going to be generated by Twilio and trusted by Twilio, so you don't have to run any PKI infrastructure yourself. This greatly simplifies, if you are manufacturing devices, the diversification of your devices on the production line. You can have your device no longer have either identifying factors or authentication credentials because they would just live on the SIM card. We will protect the SIM card through SIM like built-in features like the SIM pin and the sign-in key. And this ideally is a platform for anybody to connect to. I know I mentioned earlier the AWS integration, but this is really greater than AWS. This is the Twilio SIM connecting to any application server, and you can utilize this in your application servers as well. So thank you everybody for coming to this talk. It was really great to have you all here. If anybody here has any additional questions, you can come up afterwards and talk to me or Gerald. We also have a cryptography expert here today from the wireless team as well, Christopher Swenson, and he's sitting right here in the front, and he can help answer any other questions anybody has as well. Thank you.